We're going to learn about the law of sines today. Law of sines is basically an equation that we can use to figure out the unknown sides and the unknown angles of a triangle. Now let's start off with this triangle here. We'll call it ABC. Big A, big B, and big C right here. So those are the angles, the capital letters. And the sides opposite of these angles, we'll go ahead and name them with the lowercase letters. So the side opposite of big A, we're going to call that little a. Side opposite of big B, we're going to call that little b. Side opposite of big C, we'll call that little c. And what the law of sines says is if we take a ratio of the sine of big C over little c, that is equal to the ratio of the sine of big B over little b, which is equal to the ratio of the sine of big A over little a. You know, you could rewrite the definition so it has little c over sine of big C equal little b over the sine of big B equal little a over the sine of big A. Alright? So I'm going to show you guys how to come up with this actual definition here. It's pretty easy. We'll go to the next page. Okay, so the proof of the law of sines is pretty easy. Let's go ahead and start off with our triangle ABC. And what we've done with ABC is we've shown the height going from the base here all the way up to the top of C. This is represented as the height here. And so what we're going to do is we're going to look at these two triangles within the big triangle, and we're going to take the sine of A and write what it's equal to for this particular triangle here. Sine is opposite over hypotenuse, so we can write the sine of A is equal to h over b. We all good on that? We're going to look at this triangle here, and we're going to write the sine of B is equal to, we have the hypotenuse, the opposite over the hypotenuse, giving us h over a. So far so good with that? From here, we're going to go ahead and isolate the h value with both of these equations. We're going to multiply both sides by a. And on this equation here, we're going to multiply both sides by b. And that gives us the b's crossing, the a's crossing, and now we have b times the sine of a is equal to h, and a times the sine of b is equal to h. We have two equations that are equal to the same exact thing. They're both equal to h, which means we can set those two equations equal to each other. We can say that b times the sine of a is equal to a times the sine of b. Good? Now from here, if we were to divide both sides by, say, AB, then we'll see some cancellations. B is going to cross off here with that B, and A is going to cross off with that A. And we are left with the sine of A over little a is equal to the sine of B over little b. In example 1, we have this triangle with one angle and two sides. Two angles and one side. No. Side, angle, angle type triangle. We can figure out what the unknown sides are by using the law of sines. So here we have a big C and we have a little c here. So we have one known ratio of the proportion. we have big A here, we don't have little a. So we're going to set up a proportion that says 56 over the sine of 63 is equal to little a over the sine of 46. And that gives us the ability to solve for a. We have this proportion that only has one unknown in it, and so we can solve for a by multiplying both sides by the sine of 46. And that gives us a cancellation here, and that leaves us with a is equal to 56 times the sine of 46 over the sine of 63. And this is where our calculator comes in handy. So the first thing that you guys need to make sure on your calculator is that you're in degree mode. The calculators by default, they're on radian mode, so you need to tell your calculator to be in degree mode because we're working with these triangles here. So go to the mode button, which is right next to second. Click on it. And right now you can see that my degree is highlighted, which means that I am already in degree mode. Now, if I were to be in radian mode, it would look like that, and I would have to go over to degree and hit enter, and that would put it in the degree mode. So now that I'm in the degree mode, I want to go back to my blank screen. And to go to the blank screen, I hit second, and we'll see the upward arrow sign to tell us that we're in the second button, and mode, which will quit and take us to the blank screen. Now what we have to do is enter in 56 times the sine of 46 divided by the sine of 63. So let's take baby steps here. We have 56 times the sine of 46. I'm going to hit enter and then divide that by the sine of 63. So that gives me 45.2, which means my little a here, I'll go ahead and do approximate. Little a is approximately equal to 45.2. So I got this side here is 45.2. I need to find out little b as well. How do I find out little b? We need to figure out what big B is equal to, right? And that's pretty easy to do. We know that when we add up the angles in a triangle, they should add up to 180. And so 46 plus 63 taken away from 180 will give us angle B. So angle B is 71. So from here, we're going to come up with little b. And we can say that little b over the sine of 71 is equal to, now at this point you could use the ratio of little a and big A, or you could use the ratio of little c and big C. I'm going to use little c and big C. Anyone have any idea why I would use little c and big C? You're onto something. It's more of an it's more accurate, exactly. It's 45.2. That was an approximation, right? So by using big C and little c, I'll get more of an exact answer. And I want exactness. All right. So we're going to multiply both sides by the sine of 71. And that will give us b is equal to 56 times the sine of 71 divided by the sine of 63. So from here, we got 56 times the sine of 71 divided by, that was the sine of 63, I believe, and that gives us 59.4. So B is 59.4. And I shouldn't write equals, I should say that's approximately, right? So on this one here, same type of deal. We're going to use the law of sines to come up with the unknown sides. So we're going to start off with trying to figure out, let's see, the only side I have is 76, and so actually I need to figure out what angle B is equal to start. So let's go ahead and figure out what we could figure out either little c or little a. It doesn't matter, right? So I'm going to go for little a right now. We know that little a over the sine of 50 is equal to 76 over the sine of 96.5. So we got to multiply both sides by the sine of 50, and that gives us 76 times the sine of 50 divided by the sine of 96.5 smooth jazz FM is equal to little a. And the first period is going to be like, he's so lame. He totally used that joke on us. That's okay. So are we all coming up with 58.6? Yeah. Okay. Is that okay to assume that since we found little a, we could probably find little c on our own? Yeah. So move on to the next problem? Yeah. All right. So we've just dealt with two different kinds of triangles. Now we're dealing with this ambiguous case, which is the SSA scenario. So when we are given two sides and an angle, there's the possibility that we could come up with no triangle at all, two triangles, or just one triangle. And so instead of memorizing all this here, I'll show you guys a pretty easy way of dealing with this problem. It'll be a little bit confusing at first, but I think once you get it down, it'll be pretty darn easy. But we're going to start off this with SSA, a side, and an angle, with just one solution, just one triangle, okay? And then we're going to look at no triangle, and then we're going to look at a situation where we have two triangles, okay? So we're going to take baby steps to the confusing part. So here we have a big A, and we have a little a, and we have a little c, and that means that we're trying to find out what this angle C is equal to start off. So that's another thing that we're looking at right now. We're going from finding the side of a triangle to finding the angles of a triangle. So I'm going to set up my proportion here. I'm going to say that the sine of C over 35 is equal to the sine of 61 over 55. And so from here we're going to solve for the sine of C. So we're going to multiply both sides by 35, and that gives us the sine of C is equal to 35 times the sine of 61 divided by 55. So let's see what we get here. We have the sine of C is equal to, we got 35 times the sine of 61 divided by 55, which approximately gives 0.5566. I'll go ahead and leave it at that. So what we're trying to do right now is we're trying to figure out the angle that is produced with this given ratio. Okay? So what's the angle given a ratio of 0.556? What kind of an angle will we get here? And the only way that we can do that is by using the inverse trig button on our calculator. I mean, I kind of know what it's approximately equal to, because I know that the sine of 30 degrees is 1/2, and here we have 0.55, so I know we should be coming pretty close to 30, but we do have to use the calculator to come up with the exact value. So let's go ahead and do that. Okay, so what we want to do is use the inverse sine button. So we're going to hit second to start. And remember, that gives us the upward arrow letting us know that we've hit the second button. And then we're going to hit the sine button, which gives us the inverse sine. And remember, inverse trig says based on the ratio, what's the angle? So we're going to input the ratio of 0.5565 there into this open parenthesis spot. And instead of typing away and not being exact, what I want to do is hit second, upward arrow there, and then the negative sign, and that allows me to input my previous answer into that parenthesis spot. I'm going to close the parenthesis now and hit enter, and that gives me 33.8. So I found the angle. Okay, so we found that angle C is equal to 33.8 approximately. And based on that, we can figure out what angle B is equal to. We can add up the two existing angles that we have and come up with angle B. And once we have angle B, we can figure out what little b is equal to using the law of sine. I'm going to go ahead and make the assumption that we all can do that right now just for the sake of time. Is that okay? Yeah? So on this example, we're going to use the law of sines to find that the given information doesn't actually even make a triangle at all. Okay, so let's go ahead and set up our law of sines here. And we're going to say that the sine of 75 over 51, I probably shouldn't be writing it this way. We're going to go ahead and say the 51 over the, oh my gosh, I can't even go back and erase. I'm sorry guys that are watching. So I take it back. We're going to solve for big B here, and we're going to say the sine of 75 over 51 is equal to the sine of B, big B, over little b here. So let's go ahead and solve for the sine of B. We're going to end up with the sine of B is equal to 71 times the sine of 75 over 51. So from here, let's figure out what 71 times the sine of 75 divided by 51 is equal to. So I found that the sine of B is equal to 1.344. The sine of B is, we'll say, approximately equal to 1.344. Now, right away, some of you guys should be like, oh, wait a second here. That doesn't make any sense, right? Hopefully. That makes no sense, you guys. Think back to your sine graph. Here's 0. Here's pi over 2, pi, 3 pi over 2, 2 pi. Here's 1 and negative 1. The sine of 0 is 0. The sine of pi over 2 is 1. The sine of pi is 0. Sine of 3 pi over 2 is negative 1. The sine of 2 pi is 0. And here's our period. Here's one stamp of our function, right? It oscillates in between 1 and negative 1 the entire time. It never goes above a 1. So as soon as we see that sine of B is equal to 1.3, a value greater than 1, that should cause alarm and tell us that that cannot happen, okay? Another thing is, if you were to actually try and find the inverse sine of that particular ratio, you would end up with a calculator error, okay? So, no triangle exists with this one, okay? So, with the ambiguous case, we have a situation where sometimes we'll end up being able to make two triangles based off of the given information. And so this is where it's going to get a little bit more complex for us. But with side-side angle, the ambiguous case, we start by finding an angle that's based off a ratio. And recall for sine that from 0 to 180, there are two angles that will actually produce the same ratio. With SSA, we use the two angles to determine if there is more than one angle. So let's think about this a second. If I gave you guys the sine of theta is equal to 1/2, or say you came up with the sine of theta equals 1/2, and you're trying to find out the angle that's based off of that ratio, one angle you might tell me is 30 degrees, right? Yep. In the second quadrant, we'll also get a 1/2 as well, right? If we take 30 away from 180, that will give us 150, right? So in other words, the sine of 150 is equal to 1/2, right? Sine of 150 is equal to 1/2. So which angle do we use? Both are within the parameters of a triangle. 30 degrees is within the parameter of a triangle, and 150 degrees is within the parameter of a triangle. Which one do we use? So that's where we're going right now, okay? Let's go to this last example. Oop, too much. So this last example, example 5, we have triangle ABC. And we have angle 40 for A, little a is 54, and little b is 62. So we're going to try and figure out, to start off, we have to figure out what big B is equal to. So we're going to set up the law of sines to figure out what angle B is equal to. We say that the sine of big B over 62 is equal to the sine of 40 over 54. And from here, we're going to solve for the sine of B. We're going to multiply both sides by 62 and then take the inverse sine of whatever we get. So we're looking for angle B right now. Actually, I'll take baby steps. And so I found that the sine of B is equal to approximately 0.7380. Approximately equal to that. Now, if I take the inverse sine, I'll find that B is equal to, we got the inverse sine of this ratio going in that spot there. So let's go ahead and figure out what we should get on our calculator. So I'm getting right now that the angle B is approximately equal to 47.6. But because this is the ambiguous case, there's a possibility of another triangle. And there actually is another triangle. We're told in the directions that there are two solutions. There are two triangles here. So let's figure out what that other triangle is. Okay, so for triangle 1, we just found out that B is equal to 47.6. That's one possibility. So the sine of 47.6 here will give us that ratio of, what was it, 0.74, around there, was that it? Okay. But if you were to take 180 and subtract 47.6, it would take you all the way over here to the second quadrant and give you another angle that will produce that same ratio. So if we go 180 minus 47.6, that will give us the other possibility of angle B. We have 132.4. So with triangle 1, we have angle A is 40. We have little a is 54. And we have little b is 62. Actually, we have the same thing for triangle 2. That's the given information. So we have A is 40. We have little a is 54. And little b is 62. To find out what the other angle is, we need to add these values up and subtract them from 180. So what I've done for triangle 1 here, I added up A and B and subtracted them from 180 to get angle C here. And for triangle 2, I added up A and B and subtracted that from 180 and got 7.6. Now you guys, if you're dealing with a triangle, if you're dealing with a SSA scenario that only has one solution, for your triangle 2, when you add up the two values, when you add up the two angles here, you're going to go beyond 180, which means that you can't make another triangle. And I'll show you that situation with the first example that we had, example number 3, okay? But let me give you a visual of what's going on here. Here we have this given information here. We have angle 40 is here, 54 here, 62 is here. And first thing we did was find angle B. And we ended up, it looks like they rounded, actually. We did not round. So what happens here, you guys, is there's two possible triangles that are made. Here we have the larger triangle here, and here we have the smaller triangle here. And the way that you get that is, imagine this leg, this 54, being like a swinging leg, and you could make a triangle with the given information with the leg fully extended out this way, or you could swing this leg in and make another smaller triangle, which is right here. So if the leg is fully swung out, then we have this larger triangle, but if we swing that leg in, then we're going to make this triangle here. So we have two types of triangles that can be made based off of that given information. So let's go back to example number 3 and see how, if we were to try and find a second triangle, we actually wouldn't be able to do that. So here we have triangle 1, and we ended up, we had a angle C that we were trying to find this time around, right? We had 33.8, and if we were to take 33.8 away from 180, that would give us our other possibility. 33.8 taken away from 180, that gives us our other possibility here, 46.2. I'll go ahead and label this triangle 2. Now you guys, we're given that angle A is equal to 61. So what happens here, when we take 146.2 and add 61, we end up with 207.2. And that's above 180. So right off the bat, you're like, oh, okay, we can't have a triangle 2. That given information will not produce a second triangle, because when you add up those two angles, you go above 180. Do you guys have any questions so far?
You just have to check every time.
You'll have to check, yeah. But it's as simple, though, as subtracting from 180 and then add up the two angles. And if the two angles are less than 180, then you'll have a second triangle. But if the two angles go above 180, then you can't make a second triangle. Okay? Any other questions? No? We're all good there?